Hi everyone! Today we'll be looking at the Six Trig Ratios. Here's today's focused learning target. Given a right triangle, I will be able to find the six trig ratios by understanding their relationships. So far, we've looked at 3 different trig ratios, but today we're going to learn about 3 more, and in total we'll have 6 trig ratios. Before we take a look at the trig ratios, let's do a quick review of reciprocals. So let's say we have the fraction 3/4. What's the reciprocal of this fraction? To find the reciprocal, you just flip the numerator and the denominator, and we get 4/3. So the reciprocal of 3/4 is 4/3. Now what if we have 7/10? What's the reciprocal of this fraction? 10/7. What if we have something like -2/5? The reciprocal is 5/2. And what if I have a whole number like 3? Well, this is technically the same thing as just saying 3/1. So the reciprocal is 1/3. So you can find the reciprocal of a fraction by flipping the numerator and the denominator. Make sure not to confuse it with the word opposite. So don't be like, oh, the opposite of 3/4. Because when we say opposites, let's say we have 3/4. The opposite of 3/4 is -3/4. So taking the opposite means to change the signs. So make sure you know the difference between the reciprocal and the opposite. In this lesson, we'll be focusing on reciprocals. So here's the triangle that we've been looking at these past few lessons. Remember that the opposite and the adjacent sides depend on where you're standing. The hypotenuse is always opposite of the right angle. And we've been looking at this acronym, SOHCAHTOA, and this acronym helps us write out trig ratios. So we've seen 3 trig ratios so far. The first one, sine of theta, is the opposite side over the hypotenuse. Cosine of theta, that's the second part of the acronym, is the adjacent side over the hypotenuse. And lastly, the tangent of theta is the opposite side over the adjacent side. And we've been talking about these 3 trig ratios, and you don't have to know what exactly they mean yet. For now, we're just focusing on setting these ratios up. And today, we're also going to learn about 3 more trig ratios. So right below each trig ratio that we have right here, we're going to write out our new trig ratios. So right under sine of theta, go ahead and write this. And I'll talk about what they stand for. First, we're just writing it out. So I'm writing out 3 new trig ratios right here. And you know how technically it's not sin, it's sine, and we have cosine and also tangent. So these bottom ones are actually longer words as well. So CSC is short for cosecant. SEC is short for secant. And COT is short for cotangent. And so here we have 3 new trig functions, cosecant, secant, and cotangent. And actually, there's relationships between these three new trig functions and the three original trig functions that we've been looking at. So sine and cosecant are related to each other. Cosine and secant are related to each other, and so are tangent and cotangent. So what is the relationship between these trig functions? Well, actually, they're reciprocals of each other. So for example, the cosecant of theta is the reciprocal of sine of theta, so it's the hypotenuse over the opposite side. And the secant of theta is the reciprocal of cosine of theta, so we have the hypotenuse over the adjacent side. And the cotangent of theta is the reciprocal of tangent of theta, so we have the adjacent side over the opposite side. So here are the 6 trig ratios that we'll be looking at. And here's the same list of the 6 trig ratios. It's just with like less arrows and stuff. So maybe this is a little easier to see. So notice how sine and cosecant are pairs in a sense, cosine and secant are pairs, and tangent and cotangent are pairs. Right here, be careful. You might be tempted to think that the secant of theta is the reciprocal of sine of theta, but the relationship is between sine and cosecant, and then cosine and secant. So with these ratios in mind, let's take a look at some examples. For our first example, we have this right triangle ABC, and we are asked to find all 6 trig ratios for angle A. Similar to previous lessons, we're going to identify the different sides based on where we're standing. So here's a penguin at angle A. I decided to go with a penguin today instead of a person. Based on where this penguin is standing, this is the opposite side. And then we also have the adjacent side, the side right next to our penguin right here. And our hypotenuse is always on the opposite side of the right angle. Now we can set up our 6 trig ratios. So we know that the sine of A would be so the opposite over hypotenuse, which in this case is 24 over 25. And then the cosine of A is the adjacent side over the hypotenuse, which is, 7 over 25. And then we also have the tangent of A. So these are similar to the examples we looked at last time. So the tangent of A is the opposite side over the adjacent side. That's going to be 24 over 7. So we have these 3 original trig ratios. Now let's figure out the 3 new trig ratios. The cosecant of A is the reciprocal of sine of A. So we're going to have the hypotenuse over the opposite side. So it's 25 over 24. We're just flipping the numerator and the denominator. The secant of A is the reciprocal of the cosine of A, so the hypotenuse over the adjacent side. That's 25 over 7. And lastly, the cotangent of A is the reciprocal of tangent of A. So we have the adjacent side over the opposite side, which is 7 over 24. So once you identify each side and then find the first 3 trig ratios, you can easily find the new 3 trig ratios by thinking of the reciprocals. So let's look at another example here. We are going to find all 6 trig ratios for angle K. So here I have my penguin at angle K, and try identifying each side. We have the opposite side, and then the adjacent side, and also the hypotenuse. So based off of this, let's set up the trig ratios. So go ahead and try setting up the first 3 on your own and press play when you're ready. So our first trig ratio, sine of K, it's going to be the opposite side over the hypotenuse, so it's 5 over 13. The cosine of K is the adjacent side over the hypotenuse, so we have 12 over 13. And then the tangent of K is the opposite side over the adjacent side, so 5 over 12. And now we can find the other 3 trig ratios by thinking of reciprocals. So the cosecant of K is 13 over 5. We took the reciprocal of sine of K. Secant of K is the reciprocal of cosine of K, so we have 13 over 12. And the cotangent of K is the reciprocal of tangent of K, so 12 over 5. So here are the 6 trig ratios for angle K. And let's look at one more example. Here I have triangle XYZ, and we're going to find all 6 trig ratios for angle Z. But before I start with anything, what do you notice here? We're missing the length of the hypotenuse. What can we use to find the missing side when you're given 2 sides of a right triangle? We can use the Pythagorean theorem. So let's set it up. The theorem states that a squared plus b squared equals c squared. In this case, we're given the legs 3 and 4, and we have to find the length of the hypotenuse. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Take the square root of both sides. C is radical 25, which is just 5. So the hypotenuse length is 5. And please let me know if you have any questions on how we found that missing side. So for this example, let's place our penguin at angle Z. So we have our opposite side here, and our adjacent side right next to the penguin, and lastly, the hypotenuse across from the right angle. Let's write out each trig ratio. The sine of angle Z is the opposite over the hypotenuse, so 4 over 5. Cosine of Z is the adjacent side over the hypotenuse, so 3 over 5. And the tangent of Z is the opposite side over the adjacent side, so 4 over 3. Go ahead and try finding the other 3 trig ratios, and then press play when you're ready. So the cosecant of Z is the reciprocal of sine of Z, so it's 5 over 4. the secant of z is the reciprocal of cosine of z, so we have 5 over 3. And lastly, cotangent of z is the reciprocal of tangent of z, so 3 over 4. For this example, once we found the missing side, everything was similar to the previous examples. So just as a review, today we looked at 6 trig functions: sine, cosine, tangent, and cosecant, secant, and cotangent. The following pairs are reciprocals of each other: sine and cosecant, cosine and secant, and tangent and cotangent. Awesome job today, and please remember to submit your notes on Canvas. Thank you.